We're continuing to look at salts in solution to determine whether hydrolysis will occur and if anions in aqueous solution will alter the pH of that solution. In previous videos, I have addressed all of the molecules that you see crossed out here. So I want you to take a moment and look at the molecules that are left that are not crossed out and determine what you see in common between all of these molecules. Hopefully you noticed that hydrogen in the middle of each of these compounds. And even in this molecule here, we're going to talk about how it is really similar to the other choices that you're looking at. And so we're going to talk about these kinds of compounds and how they will change the pH of the solution. In this short video, I want to specifically address this molecule right here. So let's look at that compound now. Looking at this ammonium compound, we know that it will be 100% soluble in solution. That salt will dissociate 100% to produce ammonium ions, and it will also dissociate in a 1-to-1 ratio to produce two ions that both are capable of hydrolysis. The ammonium ion acts as an acid. We can look up its Ka value in the table, and that will show that it is a fairly weak acid. The formate ion can continue on and hydrolyze as well to form its conjugate acid, the methanoic or formic acid. And to calculate its strength as a base, we would calculate the Kb value by looking up the Ka value of the methanoic acid. And we determine in this instance that if we compare the ammonium strength as an acid to the methanoate or formate strength as a base, that the Ka value of the ammonium ion is greater than the Kb value of the methanoate. So in this case, we would say we expect this salt solution to have a pH that is less than 7. Now, because the two values are fairly close, I would suggest that perhaps it's not going to be extremely acidic, because the competition between those two ions as they release hydronium into solution and hydroxide solution suggests that they will almost equalize each other. In advanced chemistry courses, you can continue on and determine the amount of H plus produced and the amount of OH minus produced and use that to determine your excess reagent to get an accurate pH. For our purposes, we will state that this would be a slightly acidic salt.